What's going on? Okay, let's see if we can get through this now. Okay, so we left off last time. I wanted you guys to try out to do number 5 part C and number 5 part D. So they're pretty simple problems if you think about it. So number C is asking that investments in a fast-growing internet-based company sector may have an annual growth rate of close to 35%. So assume a 35% growth rate for such an investment. Compare the predicted doubling time with the actual doubling time. Okay, so it was similar to what we were doing before we logged off. And so what you're given here is an interest rate of 35%, and they want to see how close the doubling time is to what the prediction is based off of this doubling time rule, which we were given last time, right? So basically it's telling you I can double my investment based on how big my percentage is. So for part C, if my doubling time prediction is based off of the rule of 72, then I could predict that 72 divided by 35 would give me a good estimate as to how long it would take to double any kind of investment, regardless of how much money you input. Okay, so 72 divided by 35 would give us 2.0, let's say 2.06. Okay, so now how does that compare to the true amount of time in which it will take to double in value? So we use what we started with last time. So last time we were looking at a formula which would give us final value. A represented our principal, our initial investment, 1 plus the rate over n. Remember that n represents the number of times something is compounded in a year. And then to the n times t power. So in this case, we have all of the information we want essentially, because we know that just like before, we were starting with $1,000 initial investment. 1 plus the rate, you know what your rate is. It's 35%. But remember to convert that to a decimal. So it's 0.35. So you get 0.35 as a rate. Now, they didn't tell us whether this was compounding multiple times a year. Essentially, the doubling time rule only works if the compounding is only once a year. So doubling time formula can really only be used with n equals 1. Okay, so we have 1 in our denominator. And then once again, it shows up here 1 times the time, right? And then we know that we want this initial investment to double. So how long would it take to now become 2,000? Okay, so similar to what we were doing before, here this is still 2,000 equal to 1,000 times 1. Now 0.35 divided by 1 is still 0.35, and if you add 1 to it, it's 1.35 to the power of t. Okay, so this is going to help us then find out how long it really does take in comparison to the estimate. So first divide both sides by 1,000. So now you're left with 2 is equal to 1.35 to the power of t. Okay. All right, and then this is where we utilize log, because since our variable is in the exponent, you apply a log to both sides. So now you end up with the log of 2 is equal to the log of 1.35. But now, because you've applied a log, property of log allows you to bring the variable to the front as part of the numerator expression. Okay, so now t times the log, then that allows you to solve for t. So we divide both sides here. We remember you can divide by log of 1.35. Okay, log of anything is just some number. We don't know what the number is because we require a calculator for it. But essentially what you're doing is you're dividing log of 1.35 on both sides. So log cancels. Okay, so now you just have t. Okay, so now we just look for an estimate here. Log of 2 over log of 1.35. This is where we got to use some Desmos. Okay, so you can use the keyboard on the bottom here, and if you go to functions and you go to miscellaneous, you'll see the log function down here on the bottom left. So we got log of 2, and we divide that by log of 1.35. Okay, so in this case, this actual doubling time is actually closer to 2.31. Okay, so an estimate here is 2.31. So the estimate that we got before told us that we could double our investment in just a little over 2 years. Right, this was what we got before. But the reality is it's a little bit longer, 2.3, right? So it's a couple more months out of the year that it's going to take for you to double your investment. Okay, so how much greater is it? Well, 2.31 minus 2.06. That's approximately 0.25. And so if you want to know a percentage of how much larger that really is, then you could take 0.25 out of 2.06, and it tells you how much greater in terms of a percentage 2.31 is compared to 2.06. So if we wanted to find that out, it's about 12%, right? 0.12. So about 12% more. Okay, 12% more in terms of time that you'd have to wait. Okay. So that's the idea for that particular problem. This part, not so important. This is just kind of additional, right? It's how do you find how much longer you have to wait, what rate of time, right? How much larger is it? So that's one way to calculate it. All right. Any questions so far, guys? Feel free to let me know. Okay, and then let's take a look at D. And then it asks, for what range of annual interest rates does the rule of 72 provide a reasonably good estimate of doubling time for an investment paying interest compounded annually? Okay, so for part D, there wasn't really like a hard and fast answer for this. This was mostly to kind of get you to look at the table that we looked at on the previous one, right? If you had filled in the rest of the table, then you could see which interest rates provide a pretty accurate one. Notice that for some of them, including this first one, it's accurate to a sense, but it's also off by about 3 years, right? So not exactly the best estimate in terms of how close it could be. Some of them get much closer, right? So for example, this one that's 11.9 as an estimate. I'm sorry, the 12 years is an estimate, but the reality is 11.9. That's much closer. Obviously here when it's 8, interest rate of 8, here it's spot on, right? So it seems to be like the larger the interest rate, maybe the closer they are together, right? Whereas opposed to the smaller the interest rate, there's less accuracy. So that's one thing that you could have mentioned for part D. But for part D is just mostly trying to get you to find any patterns within the rule of 72. Okay, so any answer could have been okay, really. All right, so let's move on to number 6. My goal by the end of this this video is to try to be done with everything, but we'll see how that goes. Okay, so for number 6, we're given a diagram here, and so this reading here is basically a graph of Apple stock. This was between February 2008 and February 2013. Okay, so you can see that when it was not a young company, but younger than what it was now, right? The stock was valued at $124.63, right? So this puts us back in February of 2008. And then at the end here, you get a reading of how much value each stock is worth by February of 2013, right? So a period of 5 years. And then it asks, how would you describe the pattern of change in the value of Apple stock during the 5-year period? Okay, well, within maybe the first year, there's some growth. And then, so the first half of the first year, there's some growth. And then there's some loss, right? Everything that's in red typically can be read as a loss, versus green is a gain, right? So you can see that in the current, right, economic situation, you see a lot of red. If you ever look at any stocks, there's a lot of red, and that just indicates that there's been loss in value. And then after that period of whatever, something happens right around this point in time, and then you see this really kind of consistent growth. And then you get a little bit of a spike here in February 2012, then a small dip, and then this peak, right? You see this peak, and then after that, there's like a steady decline, right? So there's terms of growth, and then followed by some declines. All right, so then, right, that's kind of like the general description for that. And so now for part B, it's asking what equivalent interest rate compounded annually would yield earnings that match the stock gain. Okay, so they're asking quite a lot here, but what interest rate, right? That's the question that you're being asked to find. What interest rate, okay, would yield? Okay, would yield would mean like would give. Okay, so yield is the same thing as what would give you those earnings, right? Assuming what, right? Well, pretend that you are the person that invested money at the beginning in February 2008. Let's say you bought one stock of Apple. Well, if you bought one stock of Apple, then you've made an initial investment at that point. We'll call that A of $124.63. Okay. Since it's asking for an interest rate, basically that means that it's giving you every other piece of information. Okay, so you just got to find it. If it's compounded annually, then you know it's going to be compound interest. And because it says annually, then you know N is 1. Okay. And then finally, because it's asking what rate would give you, right, an earning that matches the stock gain, well, you have to assume that you start here in February 2008 with this value, and then you end with this value. Okay, so essentially you're being given the final value, which is 479 with 93 cents. So basically everything that you need in order to solve this problem is given to you. You just have to know where to plug it in. Okay, so let's use the compound formula. Compound interest, F equals A times 1 plus R over N to the N times T. Okay. All right, so you can start plugging in what you know. You know that the final value is 479 with 93 cents. You know that your initial investment was $124 with 63 cents. You know 1 stays the same, plus what you don't know right now is the rate, right? So you can leave R alone. You do know that N is equal to 1, so you can put a 1 underneath. And then here on the power, you know that N is 1, and then the time, this is something that you have to get from the graph, right? They don't really give you the time explicitly. They don't say 5 years, but it's February 2008 to 2013, right? So from here to there, it's 5 years. So that represents your time, right? So time is going to be 5. So you see how a lot of it is not really given to you very explicitly. You have to pull it from parts of the problem, and you have to try to read what they're asking you. Okay, so let's go ahead now and try to clean this up a little bit. 479.93 equal to 124.63. 1 plus the rate, right? R divided by 1 is just R, so I can just drop the R. And then I have this to the 5th power. Okay. Alright, so here's what we can do now. We can go ahead and divide by 124.63. Very similar approach to what we took on the previous problem. Okay, so if we go ahead and divide that, we should be getting, let's see, actually I'll use this one. Uh, 479 with 93 cents divided by 124 with 63 cents. Okay, so here let's try to round this off to about 4 digits. So we're looking at 3.8508 is going to equal, well, now this cancels, so you have 1 plus R to the 5th. Okay. All right, so despite what we learned last unit, this is not the time to use binomial theorem, okay, because this is going to get really messy, right? So then this is where you utilize the power of log instead, because the thing that's preventing you from solving the R, because it's trapped inside of those parentheses, is the power of 5. So here's where you can use something else. Use the log, okay? So if we use the log, I can apply the log on both sides. Okay, so now really what I get is the log of 3.8508 is equal to log of 1 plus R. And then because I applied the log, then the 5 comes down to the front. Okay. All right, so now from here, then what happens, right? It's a little tricky. We haven't really dealt with something quite like this before. So what do, right? The log has a variable on the inside, okay? So first, let's find out what log of 3.8508 is, okay? And let's see where that takes us. Okay, so log of 3.8508, that is 0.5855, okay. And now here, 5 times log of 1 plus R, right? And what do you predict we could do next? So we can try at least dividing both sides by 5 first. And I'm running out of space, so I'm going to keep going. gonna bring it down here. Okay, so we have 0.5855 divided by 5. All right, so really what we end up with is 0.1171 equal to the log of 1 plus r. Okay, and so now what? Okay, this is where it gets tricky, because again we haven't covered much of log, and so now it's gonna come in and it's built itself into a problem like this, where if you may have thought earlier that you could have just canceled out the logs on both sides, it doesn't quite work that way. So we have to try something else. All right, so I gotta jog my memory real quick on log. So I know one of the things about log is that log has a base of 10. Okay, and so one of the ways in which you can then eliminate log is kind of by applying a base of 10 on both sides. Okay, now I want to see if that's going to work on this side. Which I don't believe it will. Give me a second here. Okay, let me try something real quick here. Okay, so here's essentially what happens. Okay, so log has something that is called a base of 10. So typically, log and has this inherent property that it's base 10, which just means that the numbers cycle after 10. So you go from 0 up to 9, and then when you get to 10, then the number's kind of cycled over. So it's kind of a tricky thing to explain, but the idea here is that if you apply a log, we know that it allows you to bring, for example, if we go back here, if you apply a log and you had a power of 5, then that 5 allows you to drop the 5 down. Now, what happens then when you have log of some expression here, for example, such as 1 plus r, you're not really allowed to do something like distribute the log. That doesn't quite work. What you need to do here in order to free up the terms that are inside of this parentheses is to get rid of the log, you then apply a base of 10, which means that essentially what you're doing is that you are creating a base of a 10 here, and then this becomes your exponent for 10. And then for this 10 on this side, when I applied it, the exponent there became log of 1 plus r. Okay, now, because of that, then 10 and log are inverses of each other. So this base of 10 and this log, they essentially cancel out. So then it allows you to drop the 1 plus r. Meanwhile, on this side, you can take 10 to the 0.1171 power. And then this is how I got this is a 1 here, 1.309. Okay, so if ever you come to a point that log is preventing you from solving the variable that's on the inside, right? Notice how the r is what we're looking for, and it was stuck inside of the parentheses. And then what you can do is you can apply that base of 10 to both sides. And so what you get is log and base 10 cancel, right? These things cancel. 1 plus r drops. And then once you have the ability to take 10 to the power of this number here, 1.1171, you get something, right? So you get 1.309, and then that's equal to 1 plus r. Now you can solve for r by subtracting 1 on both sides. So here what you get is 0.309, right? And remember the original question, what it was asking for? It was asking us for what would be the equivalent interest rate, right? So we were looking for r the entire time. So because this is a decimal, right, I basically just moved it over 30.9%, and then I ended up rounding it to 31%. Okay, so that's approximately what we would get as an interest rate. So I know that this part is tricky here, understanding like the log and then having an expression 1 plus r on the inside. That's pretty tricky, especially because we haven't looked at properties of log, and we haven't looked at how to eliminate log once log is in the function. But basically, if you want to eliminate log because you have something trapped inside of those parentheses, you apply a base of 10, which means that you convert what is existing, right? This was the existing part of the formula. This becomes the exponent for your base of 10. And the same thing here, the log of 1 plus r becomes the exponent for your base of 10. Okay, and then that essentially you do that because you want to eliminate the log so that you can remove the variable from the inside. Okay. All right, but either way, here is our interest rate, right? So then that tells us that if you invested, right, a certain amount of money here, $124, you would have needed to find some account that would give you 31% interest, right, compounded annually to be able to yield the earnings, right, to be able to get the same earnings as if you would have gotten by investing in the stock market in an Apple stock. Okay, and that's the idea. Okay, so this is a tricky one. Okay, put a star next to this. I'll make sure that I look for another problem later this week, something like this, and we can look over it and talk about it. All right, so let's take a look at these, at least 7 and 8, try to finish up these last two. Okay, so effective rates of interest. So the annual percentage rate of interest is the rate most often quoted by banks and local credit unions, right? So that becomes your APR. Right, notice where it comes from. It's annual percentage rate, right? So APR, something that you typically see often on commercials, especially, right? They're talking about car, and they're telling you what right, what rate they're going to charge you for like a loan for your car. Okay, so its true worth depends on the number of compounding periods. Okay, so however, the APR cannot help you decide, for example, whether a savings account that pays 3.75 interest compounded quarterly is better than a savings account paying 3.7% compounded monthly, right? It doesn't really tell you which one helps you save more, because you actually have to do the calculation yourself to find out, first of all, how much am I going to invest, and then you can then decide, should I try this quarterly one or should I try the monthly one? Okay, remember that when it compounds more often in a year, typically you get a higher return. But notice that there is a difference between the level of interest between these two, right? 3.75 versus 3.7. There's an additional amount that the 3.75 has that is going to take into account once you start doing the compounding. Okay, so for comparison purposes, a better measure of worth is the effective annual interest rate or the annual percentage yield. Okay, so they sound similar. You have APR, and then which is annual percentage rate, and then you have APY, which is annual percentage yield. Okay, and it's slightly different. Okay, they mean different things. Okay, so the APY is the simple interest rate that yields the same amount after 1 year as the compounded annual percentage rate of interest. Okay, so APY is essentially just taking a look at it as a whole, like how much did I earn at the end of the year and how much more is that compared to where I started. APR is just going to tell me the rate. Okay, it's the rate at which something is building. All right. So just to give you an idea of how these look, okay, look back at the investment, the APR, and the compounding periods in problem 1. Okay, so let's go back to number 1. I have it up here. And number 1, okay, here's what we started with, right? We had $1,500 deposit, an APR of 4%, and then we had interest compounded semi-annually, quarterly, and monthly. Okay, so those are the plans that we're going to look at. And let's go down here. Okay, and the goal here is to find the APY, right? Determine the APY of each investment plan. Okay, so first you have to find out what is it that I'm going to get at the end of that first year, right? So you're going to run through it very similarly like you did with your final value formula. So F equals A times 1 plus R over N to the N times T. Okay, we know that in problem 1, what we had as an initial investment, A was $1,500. We had a rate, an APR, an annual percentage rate of 4%. Okay, N depended, right? Because we had 3 different scenarios. So here we're going to leave this one as a question mark depending on the scenario. And then the time, well, in this case it's just an annual yield. It wants to know just after 1 year. Okay, so time is 1. Okay, so the idea here is first let's find out how much money you end up with after that first year, and then we can then find a percentage as to how much, in terms of an overall percentage, how much did it actually grow. Okay, so for the first case we had quarterly, then we had, actually it was semi-annually. The first option was semi-annually. Then we had quarterly, and then we had monthly. Okay, so with a final value, that's what we're looking for. We had a $1,500 investment, 1 plus the rate at 0.04. In this case, semi-annually means that the compounding happened twice. Okay, so then we have a power of 2 times the year, which is 1. So then that's just going to be 2 times 1 to the second power. So 1,500 times 1 plus 0.02 to the second power. Okay, we can do that quickly here. That'll be 1.02 squared times 1,500. And then that gives us the final value of 1560 with 60 cents. Okay, so that's how much you earned. Right now, that was used, we found that using APR, right? Because that's where the 4% comes in, right? The rate, right? And that's what we were told at the beginning, right? That we had an annual percentage rate. Now the yield, how do you find the yield? Basically the yield is final value is equal to the final value divided by your initial. Okay, you just simply take the final value which you ended up with, which was 1560.6, divided by your initial investment, which is 1,500. Okay, this ends up giving you $1.0404. Okay, so the APY is how much did it grow, right? Well, what was the total percentage of growth? Okay, so your percentage rate told you that it was going to grow by 4% annually, right? But the compounding does something to it where it actually grows a little bit more than 4% because it actually grew by, right? If you take a look at just this part, right? The fact that 1 point shows up, it just means that it grew in addition, right? If it was less than 1, then it would have declined in growth, okay? But because it's above 1, there is growth there. So if you really want to find out that percentage, you subtract 1 and you're left with 0.0404. Okay, so then you turn that into a percentage, and then this is 4.04%. Okay, so in reality, right, the APY was equal to 4.04%, slightly bigger than the APR, right? Slightly bigger than what the annual percentage rate was. And this happened because there was some compounding that took place, right? So how much did you yield basically is how much did you earn in terms of a percentage. You earned 4.04% on top of your initial investment. Okay, that's what it means. Okay, so that's what APY is trying to tell you. Okay, it's telling you how much it will actually grow by the end of that first year, right? It grew by a little bit more than 4%. Okay, so now let's take a look at the other two. Okay, so now quarterly, same idea. You have your final. You start with your initial. You'll have 1 plus, still the same rate of 0.04, right? Because that's the APR, that's what you were told. APR 4%. Okay, so we're still using that. My N this time, because it's quarterly, is a 4. And then I have N again, so that's 4 times the time. The time is just 1. Okay, it's just 1 year. So we have 1,500 times 1 plus, here 0.04 divided by 4 is going to be 0.01 to the 4th power. Okay, so now I can take 1500 times 1.01 to the 4th to find out what the final value is going to be. Okay, so final value here should be 1.01 to the 4th times 1500. All right, so we get 1560.91. We can round it 1560.91. Okay, and so now since this is the final value, okay, we kind of go through that same process again, right? If we're looking for the APY, take your final divided by your initial. You get 1560.91 all over 1500. And so here, what we get is 1.0406. Okay, so remember that because it's above 1, that means that that's how much it grew. So if you really want to find the true percentage, subtract a 1, so you get 0.0406. And so from there, now you can convert this decimal into a percentage, so you're looking at 4.06% as your APY. That's your annual percentage yield, right? So it makes sense because when you compounded quarterly, you ended up with more money, right? It's only a few cents more. It's only about 31 cents more, but that should be reflected in your annual percentage yield, meaning that if you invest at a quarterly rate, at the end of that year, your investment has grown by 4.06% from where it started. Okay, and that's what the yield is telling you. Okay, so you're looking for a yield because it actually gives you a better reflection of how much larger my investment will be compared to when I start. Okay. And so now the monthly, same idea. Let's go ahead and run through that. So because monthly, again, if you're compounding monthly, you should end up with a larger return at the end. Then that should be reflected in the APY. So the APY for a monthly should be even larger. Okay, even though it's really small. It only went from 0.04 to 0.06. Right? In monthly, you'll see a slight increase as well. All right, so let's go ahead and run through it. So 1500, 1 plus 0.04. That's still the same rate, the annual rate at which I was going to be compounding at. Okay, but this time because it's monthly, then I have n is equal to 12. Okay, so now I have a power of 12 times time, which is just 1 year. So now we can get 1500 times 1 plus, here, let me simplify this, 0.04 divided by 12. Okay, all right, now I know that it's going to be this really long value, so let me go ahead and just add 1 to this. 1 plus 0.0033, and it keeps repeating to the 12th power. So let me go ahead and find out what that value is by doing it here. So let me just add 1 to this. Now I want to take this to the 12th power, and then now I can multiply times 1500. Okay, so I end up with a final value here of 1561 with 11 cents. Okay, so now we want to find the APY, the annual percentage yield. Go ahead and take the final value divided by the initial. 1561 with 11 cents divided by 1500. So divide this by 1500. And we get 1.0407. Okay. And so again, that's not the true APY. We first have to subtract 1 from this, so then it's 0.0407. So that means that the entire investment grew by, when I move the decimal over, 4.07%. Right, and that's what my entire investment grew by. Okay, so it basically gives you a measure of where you start and where you end after that first year. Okay, So APR just tells you what you're allowed to use in your formula, but APY gives you a better idea of which one will represent the better choice of investment. Essentially, what you want to pick is the one that's going to give me a higher yield at the end of the year. Okay, because again, it doesn't really tell you. You don't know that by when you decide whether to choose semi-annually, quarterly, or monthly. Right, those options are available to you, but you don't know which one's going to give you the best yield, right? The best gain at the end of the year. So APY gives you a better idea of that. And so that's just another measure of investment, another tool that people can use. Okay. All right. I'm going to end there. I know I lost some time. I was struggling a little bit with the live stream this morning, but I think I'll be able to finish it up by Thursday. Okay. So I think we can get through 8. I might actually skip number 8, because it's very conceptual. I don't think we need to spend too much time on that. And we'll take a look at 9 and 10 next time, and then see if we can get started on the CYU. Okay, so are there any questions for me so far about today's lesson? Double player, yeah. There's gonna be a retake. There's gonna be a redo opportunity. I'm probably going to message something about that out, probably by the end of today, if not tomorrow. About what the retake process would be, but your third period, so I'll talk to you about that in the next live stream. Okay, but my seniors, any questions for me? How we doing? You guys hanging in there okay? All right, sounds good then. Then I'll see you guys on Thursday, 9 o'clock. I'll make sure I have my stream working this time. Okay, thank you for being patient though. All right, and then again, if there's any issues, please message me. I'm trying to make this next 6 weeks about as stress-free as possible. Okay, so share with your friends that if they are struggling if their grades are low, that Alex is probably the best way to pick up their grades at the current moment. So I know those of you tuning in, especially the ones that I know are here, I know you guys are doing okay on your Alex, but just let them know, because we're probably not going to be quizzing for quite some time. We still have a lot more lessons to go. Just let them know to stay on top of it. Okay. All right, guys. Well, with that said, I'm going to sign off. And then I'll see you guys in a couple days. Okay? Have a good one.